This is a preview of a new system I'm currently building called Morphisms. Might be renamed, but the idea of the system is that it allows you to run agents with exactly the right context, exactly the right requirements, and exactly the right persona or kind of set of instructions. And it enforces movement of data through deterministic systems that require them to do their job according to a schema, according to a template that is deterministic. And the only way they can move on to the next step in a multi-dimensional system that you can design yourself and compile to check that it makes sense, the only way they can actually do this, the only way the data can move through the system is if it meets specific criteria that you can design with an agent. So let me show you how it works. So at the top, we have these things. So we have these things called the deploy, gate, observations, tasks. So these are what I've defined, and everyone can define their own what I call contracts or distributions. And distributions are made up of these things called stores. So these are stores, and they're storing records or data. So for example, when an agent is working or when you are working in a repo, it's not uncommon to find bugs, right? That's typical in software development. So you file an observation. And the typical way that I would do this previously is I would define a JSON, and then I would define a kind of ad hoc CLI for the agents to use, so they can just essentially file an observation in the JSON. And the JSON is tracked in the Git repo. But then if you want to change the schema, then you have to change the CLI, and you have to change the skill MD file. And then suddenly you have this kind of network of interconnected dependencies which are non-deterministic and can change at any moment and break, and they do. So I built this system so that you don't have to kind of deal with that. This will handle that. So the idea is, yeah, if there's an observation, you can file it into this system, and you can define the requirements for an agent to file such a thing. So within the observations, we have these things called dimensions. So every store can be made up of many dimensions, because an observation might be, you might consider it to be multi-dimensional. So for me, I consider an observation to have kind of one axis or dimension is its journey. So that is, for example, the very first thing that happens with an observation, of course, is that it's captured, right? And so there's some minimum requirements that we need for an agent to capture an observation. So these are required fields for an agent to actually deposit the observation in this store, in this dimension. At the same time, kind of orthogonal to that, an observation might eventually get a contract, right? So for example, if the observation or bug or issue is found to be a real issue, it is reproducible and it is understood and it needs to be fixed, then we will go into another dimension of observations called contracts. And this is where a contract will be drafted in order to understand what exactly is the problem and what exactly is the fix. And that's where you make sure that the intention is not lost when you work with agents. And let's say that, so that's in the store of observations. So let's say that an observation goes through the journey of becoming, understood as a real problem, and then a contract is drafted, then it can move into the tasks store, for example. And then tasks, I have at the moment 2 dimensions for tasks. Task has a journey, and a task has quality assurance at the end there. So let's look at this in detail, right? So let's look at this particular dimension. So the idea is that you think of each of these nodes as an agent. And if you think about the way that agents work, there's only actually a few variables that are really important. Obviously, the LLM that you pick is important, but the harness that you pick is also important. But once you've picked those, and those are the things you usually pick the same every single day, then the things that are really important on top of that are the persona, so the instructions for the agent. What are they doing? What's their role? What's their purpose? And what's their kind of done? Like, when are they done, right? So that's their persona. And obviously context, okay? So every single node has the persona and the context that you can define at that node. So what this means is that you have this right here, this MD file, which is essentially the agent's MD file, but it works, it's totally agnostic to the harness that you might be using. And you can edit it here. And it also has the context recipe. So for example, if we go to the investigation review node, and we look at the context there, that will require obviously the observation record, which is like the minimum requirements for an observation to be made. So it's just the basics. But it'll also have the latest capture brief. This is called an artifact. The latest investigation report, any prior investigation review, and the latest operator response. So that's coming from this operator gate, which is me, the human. So, okay, how does this work? The idea is that once an agent has filed an observation at the captured node, then the agent at that node will be responsible for moving the record out of captured into, as you can see, one of three different edges, right? So it might go into, for example, confirmed, it might go into investigation, or it might just be straight away closed. So how can it do that? Well, you can see it can cross these nodes, but the important thing is, these edges, sorry, the important thing is that each of these are guarded. This is what makes it deterministic. You force the agent to submit certain payloads or artifacts, and these themselves are defined by JSON schemas. Right? So the idea is not, do you feel like it should be investigated, or do you just do what you want with it? It's, there are three options, and in order to take any of these three options, you need to do either A, B, or C. And A, B, or C are gathering and submitting evidence into the system here. And everything is stored in a database, again, schematically enforced, however you want it to be. So for example, the investigator, when it tries to submit to the investigation review, it has to attach a investigation, right? And that investigation itself has a schema. So let me show you that here. So here's the investigation note schema, for example. So again, you can quite literally, like, this is what you can define. You define it once, it's in the system, and more than that, what is really, really important is that the system that I'm building compiles the contract that you write, and a contract is quite complicated, but the agents can write the contract, and they have extensive documentation and examples. They write the contracts with schemas, with the stores, which are written in YAML, like so, and something called the distro, which just collects them all together and defines some relations between them, and you can have a README for the store itself. I'm planning on these things being shareable, where you can actually create your own store, or your own distro, I should say, and share it. But the point here is that the system that I'm building, Morphisms, doesn't just allow you to define that, but it also allows you to compile it. And the compiling does some mathematics in the background where it's actually checking that the context that you've required, for example, all these context requirements in what's called the context recipe, that those fields exist somewhere previously. What that means is that if you say the context, for example, the latest investigation report is a required piece of context, then it's mathematically guaranteed through the compiler that by the time a record reaches that node, it must have that data. What this means is that when you require context at a certain node, and if you can compile the contract that you've written, it will be there. That is the difference between just doing this ad hoc approach where you just have scattered JSON, scattered agent MD files, skill files, plugins, all kinds of things, massive CLI scripts and bash scripts and all kinds of things that just are so brittle, and you're trying to manage this in your head. This is the solution to that problem. Okay, so let's actually zoom out a little bit. So the idea, we've talked about persona. So again, the persona of the agent there and the context required at that node. And the records can, again, be moved through this system. And because you can represent this system visually, and because you can compile it, which means that you can trust it with more certainty, you're able to actually, what I found is you're able to actually think at a higher level, right? So instead of getting bogged down in things like schemas and the CLI and the agent scripts and which agent should we pass to next, you can think at the level of topology, at the level of drawing these nodes and diagrams and about what is the purpose, what's the system that I'm trying to define. So let's go through some of those systems at a high level. So again, if an object is captured, Once an observation, I should say, is captured, then the agent at the captured node can determine either that it needs an investigation, so it'll go to the investigator, and the investigator can then submit their investigation to the reviewer, which will critique that according to their, persona here, right? And if the investigator is happy with it, then it will either pass to closed or to confirmed or to the operator. So for example, that's me. If there's some business decision, some tribal knowledge that isn't documented or something that I need to answer, then it'll pass to me. And this is my node that I have responsibility over. And I will talk with an agent to submit my answer, and then it will move on to the next bit. But let's go back to the captured. So the triage agent could, for example, immediately close an observation, maybe because it's a duplicate, because it's able to search through the entire system with a single CLI command, so it can find the duplicates very easily and very quickly, so it can just close it straight away. Or it can go straight to a kind of quick path, which is that it just confirms that it's real straight away and it's worth progressing. At the confirmed, there's one more agent here that will either decide that it's going to go into in progress, which means that a task has been created for it, or a contract will be created for it, or it might just go straight to closed again. So let's look at, for example, the contract. And I think this is a good example for what this system allows you, kind of the kinds of thinking that this system allows you to take now, right? Because you don't have to worry about, you can define the context, you can define the persona, you don't need to worry about schemas and all the other stuff that I've talked about. Now you can focus on systematizing the movement of data through a systematic and deterministic system, right? We're systematizing this, right? So a contract starts at none, obviously. So that's how it's born. So for example, you can also click here. Oh, that's not running right now, but you can actually click on each of these records and see details as well. So you can actually see the movement of data through the system. So how can a contract work? So for example, you always want a quick path, right? Maybe there's a very simple one line of code change or something like that, very simple, very trivial. So it can go straight through to quick fix draft, and then it'll go straight through to ready, which just means the contract has just been created. So it just goes through two agents there, the agent that routes it to quick fix draft, the agent that creates the draft, and then it's in a ready state, which is then now, once those states in these two dimensions, so that is, if it's stated as confirmed and the contract is in the ready state, so these are different states in different kinds of dimensions, then the agent will be able to move it into the task store, and only then, right? So you can't create a task for an observation until you have a contract and it's been confirmed. This is the reason why I've broken it up into multiple dimensions. Okay. Some other different types of drafts. I've just got two more levels of draft. So a standard draft, this is just a standard maybe one agent chain draft. So the agent will draft it. Again, you have the context and persona there, and then you get a standard review of the draft. That's really important. Now, it might go to ready. That's fine. Or the reviewer might think that actually either it's not good enough, so it'll pass it back. There's always that pressure. Or this one requires an architectural review. Right? And so that will actually pass it to an architect agent whose specific purpose is to take a big global perspective of what is the proposed fix to the problem, and does that interfere with the bigger picture of the application or system that's being built. And similar down here, we have rigorous draft and rigorous review. So this is going to create more feedback and more review. It's a little bit larger. It's going to have different schemas. It's going to require more details because it's a bigger problem or a bigger fix that's required. And again, it can always pass from rigorous review up to the architect, or it can skip and go straight to ready. And notice that the architect isn't the one that goes to ready. The architect just informs the reviewer about their perceived concern over some architectural claim. Okay, so that means that the reviewer doesn't have to do two things or more. It only has to review the draft, and if it needs an expert opinion, architectural opinion, it can pass off to that agent, and then it'll get it back in return with its answer about the concern. Okay, so we've covered how an observation can move through these two journeys. Let's suppose that, again, we've got to the point where it has a ready contract. The contract is ready, and the journey now is in confirmed. If an agent, so the agent probably in the contract store, will then actually create a task. It'll capture a task, so it'll start a task here. And one of the things that Morphisms allows is the linking of one record in one store. So in the task store, for example, it'll link it to a record, for example, in another store like the observation. So for me, at the moment, all tasks are linked to observations. These observations might be feature requests or bugs, but they're all linked to observations. So once an agent has actually filed captured a task at this node, it will link it to an observation, and in doing that, it will actually allow the, for example, journey of the observation, so it's kind of the status of the observation, to move from confirmed to in progress. That means that we currently have a task in progress for that observation. Okay, now for the tasks journey. Task journey is my favorite one, I think. We have lots of little loops that I've been using for many months, but many of them in my head, in markdown files, in plugins, in things scattered across, and it's almost impossible to change it without spending a whole day on it. Now you can change things in minutes. So when it's captured, it's routed to one of three possibilities, either quick fix, rigorous planning, or standard planning. So we essentially have three tiers of tasks. One of them is, hey, this is simple, let's fix it quickly. And the second one here is validation, because it's usually pretty straightforward. It's just making sure that the problem was fixed, and then it'll go straight to ready for QA. But the more rigorous ones, you can see there's more loops going on, right? So for example, for standard planning, we do a standard plan review that can cycle through as many times as you want. Again, you can define this. You could cap it at 3. It's all allowable by the system. But after both of them have finished their planning, they go into executing. And the only difference between the rigorous and the standard one is that the rigorous one can go through and do many phases within a task. So it'll loop through here quite a many times. Apart from even if the phase review passes, it'll still go back, and the executing will continue to the next phase. And as you can see, there's a rigorous final review versus a standard final review. Again, the point is that these are going to have, firstly, different context, right? And different personas. One of them is just reviewing a smallish task, and the other one is reviewing a larger task. And so that should require slightly different context requirements and slightly different personas, slightly different schemas as their output, right? Because one of them is large and one of them is small. Okay, that is the tasks journey. And now we can look at the QA, so this is quality assurance. And this is where I get involved, and I might even put a node for an agentic QA that has access to a browser control, like an agentic browser, or it might just do some API work in the backend, like curling the backend and just trying to stress test the system. But now the point is the task has moved into another dimension, which is essentially quality assurance, right? So starts as none, that's the default situation that it's born into. And then if it gets moved into, so it's ready for QA, then it comes into human QA. That's where I get a packet. So I will get, quite literally, there'll be an agent that creates a packet for me, which will be a link to the running. Again, this is all stuff that's not built into the system. It's stuff that you can define in the contract. But it'll create a, it'll run the server locally on the work tree, on the branch. It'll give me the link. It'll give me a packet, a QA packet for what I should check, what I should test, and what has been tested already. And then I'm actually able to decide myself, is this going to repair triage? Is it going to straight to ready for deploy, so I'm happy with it? Or am I going to abandon it? Maybe I find that the task is not actually needed anymore, so I can throw it away right away. Repair triage is basically when I say something is wrong and I give some notes, and the triage agent can either go back to a planning, so it'll plan it there, or it'll send it back to a collaborative agent that will work with me on fixing the task. And then again, a fix review goes back to ready for QA and back to human QA, right? So there's a big kind of loop here where I say something's wrong, we go and fix it, we do a review, it goes back to ready for QA, and then I can review it again, and then hopefully it's ready for deployment. And you can keep going, right? So then eventually, so what have we got? We've got an observation that was confirmed, a contract for the observation that was drafted and reviewed, and then a task that was created and gone through the executing and through human QA. And now the task is awaiting deployment. And I haven't fixed this yet. This is a mess. But The idea is that when you have a lot of tasks that you want to deploy, you need some kind of system for managing how to put them together, how to run tests, how to actually deploy them, and that's another one that I'm working on. Okay, so I hope this is interesting. I don't know when this will be available. I am planning on making it open source, but I'm just sharing this because I think it's interesting, and I would love to hear anyone's idea about things that might be worth including on the front end or the back end. I haven't shown you how the agents actually kind of interact with it, but they use a CLI, and the idea is they have a single CLI, for example, to pull down the persona, the context, and a record at that point. For example, there's a record there when I'm connected to it, and it'll be able to pull down all the information, the persona, the context, and what walks it can take, what walks it can't currently take, but what actions it can do to unlock those walks. So that's hopefully exactly the right context for a stateless agent to become stateful, do its job, and that job only.